A particular machine costs $135,000 upfront. Legislation prevents the machine from being used for more than 5 years. If sold for scrap at that time, in 5 years' time, it would be worth $9,000. If sold previously, then it will be worth $9,000 plus $14,000 per year of remaining legal use. Running and ownership costs are expected to be $35,000 in the first year and increase by $10,000 each year after. The discount rate to be used is 10%. Determine the economic life for this piece of machinery. Now we're going to calculate the annual equivalent of the running costs. For the first year this is pretty easy because it's quite simply $20,000 is a cost per year. So we put $20,000 in here. For the second one it's more complicated because we're paying $20,000 for the first year and $25,000 for the second year. So what's happening is our costs look like this. Each year they're getting bigger, but it's a straight line. Now we have a formula for this, so let's use the formula. So the formula was A1 plus G times 1 divided by I minus N divided by 1 plus I to the N minus 1. So A1 is the $20,000. G is the amount we're growing, so in this case it's $5,000 times 1 divided by the discount rate, which is 0.1, minus, we're talking about 2 years in this instance, divided by 1.1 to the power of 2 minus 1, which gives us $22,380. Now, as a sanity check, you'll notice that this is slightly less than half of these two, because remember this is closer in time to now than this is, so this will have a bigger effect. So therefore this answer will be less than the average of the two numbers. So now we recalculate this with n equals 3 and we get 24,682, 26,905 and $29,050. Now we need to deal with the salvage. Remember, the salvage is one payment that we get at the end of the life of the equipment that we now need to turn into an annual equivalent amount. So we'll use the same formula that we've been using in the past. So for the first year, we've got $30,000 times our discount rate divided by 1.1 to the power of, for the first year it will be 1 minus 1, which gives us $30,000. Not surprising, because we're looking at comparing an end of year price to an end of year price, so nothing's changed. But when we go and replace this with a 2, what we're going to find is we will get smaller numbers. So we're going to put in $25,000 times 0.1 times 1.1 to the power of 2 minus 1 gives us 11,904 we use this one for 3 years, we get $6,042. For this one, we're going to get $3,232, and for this one, we're going to get $1,637. So now we add up these orange values to give us our total annual equivalent. So for the first one, 110 plus 20 gives us 130, minus 30 gives us 100,000. For 2 years, we get $68,095. For 3 years, we get $58,852. For 4 years, we get $55,220. And for 5 years, we're going to get $53,792. So now we compare these numbers, and what we find in this case, our smallest annual equivalent cost is $53,792, which tells us that we should keep this particular machinery for the full 5 years. Of course, if we had different values, if the running costs got bigger quicker, we might have found that one of the earlier lives would have been cheaper.